Okay, again, I can't stress this enough, but just like before, addition, subtraction, you can only add and subtract when things are alike. You can multiply and divide anything. So if we're asked to add two numbers in scientific notation, if they're alike, and what I mean by alike is notice the times 10 to the fourth, what they're being multiplied by. The same way if I had 3x squared plus 4x squared. The number out front tells you that's your coefficient, how many you have. And if these things right here are alike, they can be added. So when you add 3x squared and 4x squared, you get 7, and you leave the x squared alone. Same way here. You have 3.5 times 10 to the fourth. You have 2.7 times 10 to the fourth. You're going to add the 2.5 and 3.7, which gives you 6.2 times, and that part stays the same. Subtraction works the same way. However, on this problem, notice they're not the same. However, you can make them the same. If it's scientific notation, so we have 9.3 times 10 to the fourth. There's two different ways you can do this. This decimal, this 10 to the fourth power, means I've got to move this decimal 4 places to the right. So if I were to go ahead and move it over once and put it right here, that'd now be times 10 to the third, because now you wouldn't have to move it over that 4 times. You can do it that way, or you can change the second one. Times 10 to the third means I need to take this decimal, move it over 3 times. However, what if I moved it once left? Now I'm going to have to take that decimal and move it an extra time to the right. So what I'm going to do is I'm going to leave that the same, and I'm going to write this as 0.64 times 10 to the, and now I've got to move it over an extra time, so now it's times 10 to the fourth. Once they're alike, because we're subtracting here, once those 10 to the fourths are alike, now we can subtract. We got to simply take your coefficients and subtract them, and I get 8.66, and again, times 10 to the fourth stays the same. When you're adding, subtracting, those will always stay the same. Again, however, when you're multiplying, let's go ahead and skip to this one. When you're multiplying things together, you can multiply anything. You can divide anything, but you only combine the pieces that are alike. So like 2.1 times 3, we can do that. That's going to be 6.3. But you also have to combine your tens on this when you're multiplying or dividing. That'd be times 10 to the, and we're just counting. This is 4 tens times 2 more tens. That'd be times 10 to the 6. Pretty much what I did there was I used my basic rules of exponents. When you have 4 of something and 2 more of something, you have 6 of them. You add those exponents. So we'll work one more of those. Let's skip down to number 6. 7.2 times 2.1, they can be combined. And that gives you 15.12 times 10 to the, and we're going to combine these. Negative 4, positive 5, when you multiply those out, you get 10 to the first power, which honestly, it would be completely pointless to write that in scientific notation because that simply says move your decimal over once. The answer is going to be 151.2. But just a reminder, if you wanted to write it in scientific notation, the decimal's in the wrong place in your answer. You want your decimal right here. As it's written, I've only got to move my decimal over one time. However, if I want to put it where it's supposed to be, now in order to get my answer, I'd have to move it over twice because I moved it once to the left, so therefore I've got to tack an extra power on there. Division works the exact same way. Let's go ahead and do number 8 here. So we're going to do 1.3 and 2.5. We can, in order to divide these, again, notice there's no plus or minus signs. There's no distributive. We don't have to worry about it. So what we're going to do to divide, you're only going to divide the things that are alike. And I get 0.52 times 10 to the, we're going to combine these as well. Now, what I like to do, anytime I have a negative exponent, I like to move that thing. So I have 10 to the negative 4 over 10 to the 5th. If I have a negative exponent, I like to move it. A negative comes to the bottom if it's on top. So I already have 5 down here. I'm putting 4 more. So now I have 10 to the 9th on bottom. However, any time you're doing scientific notation, they'll always write their answers with all the exponents on top. So it's going to become a negative 9 when it comes back to the top. Now this one, again, it's not in scientific notation. The decimal's in the wrong place. We need it right here. So I have to go through this process. This is my thought process. This 10 to the negative 9 says I'm going to take my decimal and I'm going to move it 9 places to the left. However, if I want to put it here instead, now instead of having to move it 9 places to the left to get in the right spot, now I would have to move it an extra times. So that's going to be times 10 to the negative 10 power now. So it'd have to move 10 times versus the 9 times if you were to put it in the correct spot.